Hey everyone, this is Josh again with a quick tutorial on optimizing art for video games. The tricky thing about game art is that the art needs to be efficient for the computer to use. This keeps the size of the game file smaller and it helps prevent it from lagging, so here are a few things you should keep in mind when making game art. So for the first tip, make sure that the resolution on the art that you design is relatively small. Now it's my understanding that artists need to work at a very large resolution when they're making their art. But these images should always be scaled down before sending them to the programmers. A good example would be this statue right here. Now if I take it and drag it into the scene, you can see that it's very large, and this is because it was given to us at its original resolution. Now the images can be scaled down, just like so. And now the image fits into the game, but the image file that it comes from is still very large. And this will cause the file size of the game itself to take up a large amount of memory when it's installed. There's also some resolutions that Unity can't even process. If it's too big, it won't understand how to import it into the system. So as a good rule of thumb, an asset should never be submitted if it has a larger resolution than 2048 by 2048 pixels. For the second tip, make sure that any art you make has the least amount of transparency possible. Transparency is something that's bound to pop up in game art. If an object isn't totally rectangular, it's going to need a little bit. But transparency actually uses a pretty decent amount of memory, even though visually it's just empty space. So, for instance, this grass asset right here doesn't look very big. It doesn't look like it takes up very much room. However, if you open it up in a paint program, you can see that it's actually a rather large asset, and most of that's being used up by transparency. Now, a good chunk of that can be removed. Pretty much everything here could be cut out of the image and there'd be no harm done. You could also cut out this little side here. And that would make the image much smaller and take up less memory. Also be sure to double check your art to make sure there aren't any holes in it that transparency is poking through, and try to avoid using low opacity colors over transparency. An example would be this image here. This was partially the art style of the game. You'll notice near the edges you have this kind of light shading that's been done, and that's still handling transparency and color as well, so that's something that's going to bog down the memory a little bit. As a rule of thumb, always try and cover up transparency fully. Moving on to tip number 3, and this is kind of a weird one. Be sure to always use power of 2 texture resolutions when the option is available. Since most of the game development we do is for mobile devices, Unity uses something called MIP mapping to store multiple copies of an image at different resolutions. This helps the game images look better when they're at different sizes, but it will only work when the textures have a width and a height that is a power of 2. This is some examples of powers of 2 right here for the people who aren't math inclined. So as you can see here on this block, I've checked generate MIP maps, and it's giving me a warning at the bottom that says only power of 2 texture can be compressed if MIP maps are enabled. So pretty much all you need to do is make sure that the dimensions of an image that you're constructing have some power of 2. It can be in any combination, you know, it doesn't have to be 2 of the same. You could do like 32 by 64 or anything like that. They just need to use these numbers. And now for our last tip, try to use the least number of animation frames possible. Animations are a bit tricky to design efficiently for games. Every frame of an animation is an individual image, so a single animated object can easily take up a lot more room than a stationary one. So because of this, it's important to reduce the number of frames used. Now, I've been given a lot of animations that use a lot of frames to create smooth motion, but that's really not necessary. For instance, we have this archer here. If I hit his animation, that looks pretty good. You can tell what's going on, everything's relatively smooth. Now, the original animation I was given is actually 46 frames to create a very smooth turn, fire, and then return to his original position. But that's really not necessary. This is the animation you actually saw. I cut out a bunch of the frames, it's down to about 15 now. And you'll notice that it only goes from his starting position to his firing. That's because the animation can actually be, you can reuse frames. So I can use these first few frames to show him drawing the bow, firing it, and then I can reuse the original frames in reverse to show him returning to his original position. Now there's one other thing that needs to be considered. I've also received animations where the animator used duplicates of the same frame to try and get a particular speed on the animation. They wanted it to go slowly, so they added more frames to kind of buffer it a bit. That's not necessary either. We only need the frames that actually change the motion of the object. If you look down here back at the animation I was doing before, right now it's going through at a nice speed, and I've told to run 30 samples, but you can up that speed just like so. We can set it to, say, 60, and now it's running twice as fast. I can also slow it way down, and it just spreads out how long it takes to go from one animation frame to the next. So whenever there's a particular speed the animation needs to go at, all we need is the frames that change the position of the object, and then if we could be given like a GIF animation that can demonstrate what speed the animation should be running at, we can match that inside Unity. Alright everyone, and that's all there is to it. Thanks for watching this video, and let's make some awesome games.